Hello friends, this is Joe here with my second video on my series of basic and easy solar power. In my first video I described the many useful things that can be done with only 5 volts. If you haven't seen it yet, hopefully you'll find it useful. As many useful things as there are at 5 volts, from lighting and device charging even up to ventilation, there are some things that require a more robust system. So today, going up to 12 volts. In addition to some nice things, there are a few that may actually be critical. The heart of a 12 volt system is the battery. I'm only going to be describing lead acid batteries today. There are some other types available, such as lithium iron, not the lithium ion as is used in some small devices, lithium iron. I'm going to be limiting this discussion to lead acid batteries because they are really the ones that are going to be affordable and are commonly used in small scale solar systems. Your car battery is an example of a lead acid battery, but it's not one that you would use in a solar system. A car battery has a great many very thin plates. It is able to generate a lot of current very quickly, such as for starting a vehicle. However, it is not designed to be deep cycled. When you deep cycle a lead acid battery, the changes in the plate chemistry will cause thin plates to literally erode away. A dozen cycles at most will typically kill a car battery. You need one more like this. This is a sealed gel cell. The plates are thicker. They are surrounded by the electrolyte held in place. They can take being deep cycled considerably more, maybe down to 80% without suffering too badly. All lead acid batteries, regardless of mechanics, prefer to be kept fully charged, but some can tolerate a deep discharge more than others. A gel cell like this is a good example. Marine batteries are sort of a hybrid. They have much thicker plates. If you deep cycle them, they'll last a few hundred cycles at most. An AGM battery perhaps goes even beyond what the gel cell offers. The electrolyte is in a matrix of fiberglass around the plates. They're held more securely, more radiation, more vibration resistant, and can deal with being deep cycled. 80% wouldn't be too unusual. Lead acid batteries are typically rated in ampere hours, although that number is not straightforward because there are a few rules that apply. This one is a 21 ampere hour battery. The rating is typically what's called the 20C rate. In other words, if the battery is drained by a load that will drain it completely in 20 hours, how much power did you get out of it? In this case, a load a little over an ampere will drain it in about 20 hours. There is something called Puchrit's law, which basically says that the faster you drain a lead acid battery, the less of its rated output you'll get out of it. If I put a 5 amp load on this battery, I'm not going to get 4 hours out of it. I might get 3.5 if I'm lucky. Might be a little more than 3. Each battery type has a Puchrit coefficient which tells how strong this effect is. A flooded battery like your car battery will have a Puchrit number as high as 1.6, maybe as good as 1.4. A gel cell like this might be 1.25. Some AGM batteries will have a Puchrit number as low as 1.08 or even 1.05. They're still affected, but not as much. If you increase your battery capacity, you'll get a better than linear improvement in your run times because not only are you adding capacity, you are decreasing the percentage that your drain is and thus lessening the effect of Puchrit's law. So what can we do with 12 volts? Nice thing you might do on a business trip in particular, charge a laptop and plug this into your car into a solar system, charge up a laptop with it. You cannot do this with 5 volts. You got a remote location where you don't have, or maybe can't or shouldn't run a generator. You might have some tools to be charged. This is a Ryobi ONE+ tool battery charger. This is one on a 12 volt system. I mentioned a critical need. If you or a member of your group is diabetic and has a supply of insulin which must be kept refrigerated, you'll need something at least like this. This is a thermoelectric cooler. It needs about 60 watts, 5 amps on a 12 volt system, and will keep things cool, whether it's food for a trip, you know, a couple pounds of bacon, a couple 6-packs, other things in here, carton of eggs. Good for a trip, but it's also good to cool insulin. If you have or need a CPAP machine to assist you to breathe at night, some of those are available that run on 12 volts. And if yours requires 120, you can use an inverter, such as this one, attached to a 12 volt system, to get your 120 volts from it. Aside from the battery, another component you will need in a solar system is the charge controller, such as this one. The voltage of a nominal 12 volt solar panel is actually closer to 17 volts or a little higher. This cuts it down to the 13.5 to 14.5 volts needed depending on the state of charge of the batteries. Keep them charged or topped off. This panel is perhaps the smallest you'd use, good for keeping batteries charged or topped off. If you've got a remote cabin, you might have something like this on it. Keeps the battery charged so that when you're there on a weekend, you can have lights, a radio, maybe a few other things kept ready by the panel this size. If you're going to use the system for heavier loads or more often, you'll want larger panels. Personally, I like Renogy panels. I have a few of their 100 watt panels. You can typically find deals on those. They cost close to $150 or more, but if you look for a deal, you can get them down to around $100 for a 100 watt panel. That's what I paid for my last one. Put them together and you might come up with something like this. Goal Zero makes a power box. They've got their 130 with a 14 ampere hour battery. Looks nicer than this. This one's got a 14 ampere hour battery, and I could put a bigger one in here. I mean to do that sooner rather than later. Power switch shows you the voltage, which will tell you the state of charge of the battery. It has USB as well as 12 volt outputs. And unlike the Goal Zero, mine has the charge controller built in. All I have to do is connect my solar panels to these connectors up here, and I'll keep my box nicely charged for when I need it on a trip. It's all compact. It's heavy because of the lead acid battery, but it's not unmanageable. And that's about it for 12 volts. Simple. And I will do at least one more video getting into some larger scale systems of 120 volts and running more things with them.